Right, let's look at exercise 3, question 2. We have been told magnitude of an interior angle of a certain regular polygon is 140 degrees. Find the number of sides of the polygon. Alright, so there are two methods to deal with this question. So let's look at both the methods. What's method 1? What's the method 1? First we'll write how do we find the value of or the size of, let's say size of one interior angle. One interior angle in a regular polygon. How do we find the size of one interior angle of a regular polygon? For that, what we do is, first we have to know the sum of all the angles. Sum of the interior angles of that polygon, sum of the interior angles divided by what? The number of sides the polygon has. So this is the way to find the size of one interior angle in a regular polygon. Now for an example, now when it comes to a triangle, in an equilateral triangle, the equilateral triangle is a special name we give to a regular triangle. We don't say regular triangle, instead we say equilateral triangle. So how to find the magnitude of one angle? What do we do? What is the addition of all three angles? In a triangle, the addition of all three is 180. So sum of the interior angles is 180. If you have to find the magnitude of one angle, what do we do? Divide by 3. Then we get to know one angle is 60 degrees. This example was just shown for you to understand this formula. What is it? Size of one interior angle in a regular polygon is equal to what? Sum of the interior angles divided by n. N means the number of sides. So let's plug in values now. Do we know the size of one interior angle? Have they given to us? Yes, they have. They have given it. They have said it's 140. So it's 140 equals. What is the sum of the interior angles? Now, have they given us the sum? No. So how can we find the sum of the interior angles? We know the formula. What is it? What is sum of the interior angles equal to? 180 times n minus 2. Any polygon, you can find the sum of the interior angles by doing 180 times n minus 2 divided by n. N means number of sides. This polygon, we don't know the number of sides yet. So you got to write n as it is. So 140 equals, let's do the numerator. We are trying to find the sum. So 180 times. Now to find the sum of the interior angles, in the place of this blue color n, what we got to write is the number of sides. But there's a problem. Do we know the number of sides? Have they given us the number of sides? No, they haven't. So we can't replace n with a number. We'll have to repeat writing n. Minus 2 divided by n. Right. So what is our next? So what should we do now? We got to find out n's value. How do we find out n's value? So there are multiple ways to solve this equation. I'll just show you one way. So 140. We can ask this division n, this black color division n, to go other side. So when division n goes other side, what does it become? It becomes multiplication n. Alright. And numerator will remove the brackets. 180 times n is 180n. Then 180 times minus 2 is minus 360. Right. So now we have ends in both the sides. Let's collect them into one side. Shall we collect all the ends into right hand side? So 180n is already there. Let's ask this 140n. 140 times n means 140n. So let's ask the 140n to go to other side. So when 140n goes other side, what does it become? When it's in the left, it's plus 140n. So when it goes other side, it becomes what? Minus 140n. And let's ask this minus 360 to go to other side. When minus 360 goes other side, what does it become? Plus 360 or simply 360. I don't have space to go down, so shall I continue? Or let's go to the next, let's take these workings and go to the next page. All right, so we have 360 is equal to, what is 180n minus 140n? That is 40n when we subtract. So what's n's value? 360 times 40 goes other side. What does it become? Division 40. So n is equal to 360 divided by 40, which is 9. So this polygon has 9 sides. This is one way of doing the one way of solving this problem. But since this method is quite long, we have another method. Let's look at the second method. Let's do method 2. Let's go to the next page. Right. Let's see what the second method is. Let's call that as method 2. It's up to you with whatever the method that is easy for you can be used. Method 2. Right. They have told us magnitude of an interior angle of a certain regular polygon is 140 degrees. Okay, let me just draw. We don't know I can't draw the entire regular polygon because I don't know the number of sides. I'll just draw 2 vertices of the polygon. Since I don't know how many sides the polygon has, I can't be drawing the entire thing. I just drew 2 vertices. So what are they saying? They're saying interior angle is 140. This inside angle is 140. They're saying inside angle is 140. The interior angle. If an interior angle is 140, if I extend this line, I get an angle here. Look at this orange angle. What is this orange angle? That is outside the polygon. What do we call this orange angle as? This is exterior angle. And what about this line? Look at this line that I'm highlighting in green. It's a straight line, right? If it's a straight line, you can apply the 180 rule. When we add this 140, this blue color angle 140 and this orange angle, what should we get as the answer? We should get 180 as the answer. So if the blue angle is 140, what should be the orange angle's value? 180 minus 140, which is 40 degrees. So what does that mean? In this polygon, all the exterior angles are 40. At each vertex, there will be a 40 degree exterior angle. So let's write that. So they have given the value of one interior angle. Let's write that. Value of one interior angle equals 140 degrees. So therefore, what can we say? Therefore, value of one exterior angle has to be what? From 180 degrees. Why 180? At each point, if you add the exterior angle with the interior angle, if you add this blue angle with this red orange angle, it will make 180. Why? It's a straight line. So 180 minus 140, which is 40. Right. And what's the other fact you got to know? That is, if we add all the exterior angles, if we take from each vertex of this polygon, if we take one exterior angle and add together, what should we get as the answer? 360 degrees. Why? Because there's a rule which says sum of the exterior angles, any polygon, sum of the exterior angles is equal to 360 degrees. From each vertex, if we take one exterior angle and add those together, what do we get? What do we get as the answer? 360 degrees. So using this 40 and this 360, we can find the number of vertices. The number of vertices the polygon has, or the number of exterior angles this polygon has. How? 360 divided by 40. To make an addition, to get a total of 360, how many 40s to be added together? That's what we get when we divide 360 by 40. That's 9. So 9 40s should get together to make the total of 360 degrees. What does that mean? This polygon has 9 vertices. If the polygon has 9 vertices, how many sides should it have? 9 sides. If a polygon has 9 vertices, how many sides the polygon has? 9 sides. So number of sides equals 9. Alright. What is the name of this polygon? Right. So what do we call a 9-sided polygon as? A 9-sided polygon, a 9-sided regular polygon. Was a special name we give to a 9-sided regular polygon. It is called as what? Regular 9-sided. For a 9-sided polygon, what is the fancy name we give? We call it as a nonagon. Nonagon. So what is the special name we can give to this polygon? It's a regular nonagon. Nonagon is the fancy name we give to a 9-sided polygon. Alright. If you're wondering how the word nonagon came, it just comes from Latin. Alright. This is not a It is not an original English word. This is a word borrowed from a language called Latin. Latin is a old language which was spoken a very long time ago. So there are a lot of mathematical terms and also scientific terms. In maths and science, we use Latin a lot. So most of the polygon names are coming, or the words have been borrowed from Latin. These English words are not original English words. These are words borrowed from the language of Latin. So even the word nonagon has some connection with Latin. All right.